And hi friends, we are live. Today I thought I would talk a little bit about building some custom controls. And one of the things I really like to work with is custom panels. And custom panels are actually really, really cool because that's sort of like the base for a lot of the controls you work every day. Examples of that is like your grid, your stack panel, um, the wrap panels, the tab panels, dock panels, canvas. They're all actually panels, and what they have in common is they're basically a collection of other controls, and they then drive how the different things are going to lay out. And so there's a lot of use for them to make some really advanced controls. One of the things I really made me like realize, wow, this is amazing, is the guy that took a list view panel and completely re-architected so it looked like a solar system. So it's sort of the power you can have with these controls. Let's actually just quickly dive over. So here's actually the doc for WPF for a panel. So this is the panel class. And you can actually see that a bunch of the stuff that derives here, this canvas, dock panel, grid, stack panel, virtualizing, a whole bunch of things. And if you're a UWP developer or WinUI, it's really kind of the same thing. There's a panel, there's a little fewer derived classes here that are directly derived, but all the concepts are actually the same. So anything we do here, we can do with WPF, UWP, WinUI, doesn't really matter. A lot of the models are the exact same. And typically how this stuff works is that there's a set of layout steps that this thing goes through. And the first thing is called the measure step. And so when a panel tries to lay out the elements, the first thing is, well, how big are the text block and the grid and the whatever you might have on your view? So we first measure all the objects. And then after that, we have an idea of, okay, this is how much size that they, or how big they are. We then decide, well, where can we put them on the screen? And that's called the arrange step. And the measure step is definitely more expensive because it has to do with the calculations. For instance, with text, has to measure how big each character is and figure out how big is that text going to be on screen. And so you can choose to do both measure and arrange or just an arrange if you already have measured. So we can kind of do some optimizing things there. So I was thinking we should just go and build some random panel, and on the chat, feel free to jump in and have ideas for how we can change the panel and do something fun with it. A really good exercise is actually just to try and build the grid control from scratch. It was sort of pointless because you have a grid control, but it actually really helps you understand how the panel layout cycles work. And I'm thinking we just start out with there, and then we kind of probably just diverge into something more custom with that grid. But feel free to swing out ideas, and we just kind of wing it as we go. So just real quick, if I go and look at framework element on my panel, and I go down to methods, you will see there is measure override. So measure override is that first step, and we'll get an available size. So this basically tells us this is how much size or how much space you have available on your view. And you have to return a size, and that size you return is how much you would think you need if you had that available size. That doesn't mean that's the size you're going to get available, but that's part of the measure step to figure out for all the controls in the entire UI3. And the next one is a range override. So here I actually get, okay, this is the size you then are allocated. That might be less than what you asked for. And again, you return the size that you ended up using. So that gives us all the power we have to actually place our child elements within the confines that we got. All right, so I'm just going to create a new project. And really, it doesn't matter if we create WPF, WinUI, UWP. But I figured since WinUI is brand new, it was fun to play with the new stuff. Why not go WinUI and hit all the bugs that we probably find doing that? But everything here is really the same on all the platforms. The namespace might just be slightly different. So we can build a blank app and put it on panel. I like to put my custom controls in the class library. So I'm just going to put my controls library. I'm going to create a new project. Our min versions we're not going to worry too much about today. And we're waiting for that project, and then we'll create a second project right after. That's the app project we can actually test this in. So there is our project. Oops, and here is my class. I'm going to rename that to, I don't know, my panel, maybe. Yes, I want to rename the class too. I love this feature. It renames the class too when I change the file name. And that, did we say that's going to be a panel? And we're going to include the namespace, Microsoft UI. So now we have to be careful because we could hit the Windows UI because we are also referencing UWP here, but we need the Microsoft UI because that's the UI framework we're currently using. And let's add a second project. Let me just do a blank app, my test app. Oh, I did that wrong. Blank app. Oh, that was a search. My test app. There we go. And last but not least, add a reference to my control library. Of course, I don't have to have a control lab. I could just done this in my project. I think it's a nice encapsulation to have. And so we want that as my starter project. And I like to just make sure things builds and runs before we go much further, just in case there is some interesting bug. Build succeeded. Oh, we can't do any CPU. Let's try again. And let's see if my app runs. It's going to be the most interesting app in the world. And there we go. There's a nice little test app, and we're almost done. So let's go and add our control first. So the first thing we'll do is we will include my control library. And so that was my controls library. And let's say my panel. And so this panel is, since it's a panel, needs some child controls. So let's put maybe some text blocks in here to start with. Text equals first item. Just copy some more. Second, third, fourth. If I can spell it. There we go. And let's run. Hopefully you can guess what's going to happen. We're going to see 4 text blocks, I hope. And nope. There is nothing there. My text block is not working. Why is that? Well, we never actually told the UI stack how to lay these things out. And so I was measuring, there was 2 things we needed to do. We need to override the measure and then override the range. So again, this is the first one. This is the one that determines the sizes of all our elements. And the next one is placing them. So we'll just kind of be lazy here and say for each, for child and children, child and measure, available size. And I'm just going to return this just because I'm lazy. And let's try now. So now, if let's set a breakpoint here. And if you look at child dot desired size, it's called. It's currently saying that its desired size is 0,0, which is not the size you want. And we're currently saying you're given 1200 by 900 pixels to put this child. So after we measured it, it said, oh, now it's 58.19. So let's just do the other one. See this one, the text is a little bit longer, so it's a little bit bigger. We now have all the sizes. And if we now look at our panel, we still don't see anything because we still haven't told it where to put him. So let's do a range as well. And so a range takes a rectangle. So that's basically like top, left, and the width and height. So we just use a new rect 0, 0, child at desired size, height. And again, I'm just gonna do it really short and just skip the final size here, and we're just gonna return. Say we use all the size that we got available. We might not really need that, but let's see what's gonna happen. And we now see text blocks in a big mess right on top of each other, which makes sense because we put all of them at 0, 0. Probably not what we wanted. So we could just do something simple like, let's define y and then say we're gonna arrange this right there and say I equals plus child at desired size dot height. So basically now we just keep moving each control down. And now with a little luck, we basically just created the stack panel. So here's a simple implementation of the stack panel to some extent. So one thing I like to do is to better understand my layout is I like to give them some background. So I'm just going to, this is a background of, let's say, red. Background, I really like cornflower blue for some reason. I think it's uppercase. Or not. There we go. So we don't see anything red, and that makes sense because we said that the panel returning, let's go back, saying just the size that you got, and that is actually the entire size of the view. So this is all you get to have, and so it filled up the entire view. If we were being a little bit smart, we can say, well, at least we know the height. So we could say new size, width, comma y, so that would be the height. And now you see what happens. We only actually get the height, but it went down, and that's really the parent panel, the grid that we put in, that decides, well, I'm going to put your center as your default. Of course, we can control that just by going on the grid and change the orientation there. But another thing I actually found really useful when you are doing these kind of things is test these lines inside of scroll viewer, because scroll viewer is sort of evil. I want to show what happens when I do this, and I now do a measure. So now my available size is 1200 in width, but I get infinity in height, which is a lot of space. So because I can scroll, I can just kind of have as much size as I want. And you got to be a little bit careful with that, because you know, we might not want to return that size, but it doesn't really change much in this case because we don't actually use this much. But let's just for fun say, what if I said final size dot height times 4? Just say I actually ended up using more than I was given. So again, we get available size of infinity vertically, but instantly enough, the final size height is not that anymore. But that doesn't mean we can't actually use more. We just have to be careful. So let me move this breakpoint. And I had hoped I would be able to, actually that won't work, because I won't be able to scroll here. Because I didn't say actually that I'm gonna use the right size here. So let's actually create a new size. That's probably actually a good idea here to measure the same thing. These really should match up. So we'll return a new size, available size width, and then let's just for fun just say I'm going to use 5,000 pixels because you got infinity, so 5,000 should be okay. And then we could say here we are going to use 5,000. And now I still cannot scroll, oddly enough. That is interesting. Let me see, what am I missing here? Oh, I know. I shouldn't return the base. I should be returning my size. I was relying on the default implementation. I don't know what I'm thinking here. So let's try that again. Now I can scroll up and down because I actually said I used up more. So if you end up having so many controls that you're taking up more space, the scroll view automatically knows, well, now I need to show the scroll viewer. Up, down, up, down. So that's all awesome. But I probably should only say I only need that. And then the same here. I could even be smart and say I don't really need the full width either. So I could say double width equals 0, and then we're just going to keep saying the width is the max of the current width that we have, and child at desired size dot width. And so now we're basically saying this is, I'm just going to return the widest of all the text boxes. And so I would actually do something similar down here. With make sure we assign that one too. Oh, got a little mistake right here. And so hopefully now we'll see the blue area. Oh, that didn't work. Oh, hold on. That is not right. Width, why? Gotta get your parameters right. There we go. Now it's nicely centered. However, what happens if I were to say horizontal alignment stretch? Just to make sure it actually does this. Horizontal content alignment. So now it should stretch everything inside. And let's see what happens to the values we get now. So even though I say I have more size, I can say I don't need that much. But I could in the end say, well, even though you didn't need that much, I'm going to give you a lot more. So now we're told you have 1200, which is fine. And I'm now getting the full size here. But let's see what's going to happen here. The same result. So because we didn't actually really choose to use the final size. We don't have to use it, but it might be a good idea to just stretch it out. But basically, this is just a stack panel. I think I want to make it a little more interesting. I think something I do a lot is you do like a label and a value and a label and a value and a label and a value, and it's kind of gets tedious. So if you were to write value 1, something like 1, 2, 3, 4, value 2, some other stuff, maybe it's a dollar amount or something. And then if we have to do this in a grid, we have to like grid.row, and grid.column, oops, not column span, column, and just kind of tedious. Why don't we just say like, we could just do this automatically. So we could basically just keep changing the row every other time, and we can use the arrange for that. So measure, we're still going to measure how big is each text, and let's do a counter here. And then we'll only add to the height every other time. So if I modulus 2, 0, we'll add to the height. So that means the first time, oh, we gotta increase I. I'm gonna increase the first time. So now I is 1, which means this is false. We don't add to it. But then we need to, yeah, this is going to be a little more tricky. Now we have to add the previous plus the second one. We'll get back to that in a minute. And then at the end, I believe we still have to probably add this in the end. Let's get back to that. And so they will do something similar up here when we arrange it. So we'll only do that there. And so now we actually have to insert this by whatever width we had last time. So we say double x 0. So we'll put it at X. And so if this is a new line, we'll set X to 0, else we'll say X plus equals the desired size dot width, right? And then for the next time around, we'll basically insert that a little bit further. And then, actually, let's always do, wait, hold on. Let's calculate the width up here. Gotta be a little clever about this. We'll add to the X, and then we take X, so we get the right width. So now it's the max width of previous plot next, and then we'll just reset it if we have to go one line down. And then we arrange it on that location. That sounds about right. So this is that. That's the size. Yeah, I think we're good here. This one probably needs a little bit of similar work. We'll rearrange this a little bit. We'll calculate the width first. And we need the X up here. So it kind of seems duplicate. You're doing the same thing in both. But you can actually start doing very different things with these two. And they actually at some point can diverge quite significantly. Because one is just like, if you had this much space, what would you like to do? But you might get up a very different behavior when you actually end up within the final size. So we have X. We're going to basically just copy this up here. So now it's the max of those values. And here we'll reset X if we go to a new line. And with X, that looks about right. Yeah, let's try it. Let's see what this looks like. Oh, here we have value 1, value 2. Pretty simple to do. And we ended up using just the space we needed. We don't have to do that. But in this case, we said we want to use all the space we need, or just a little bit of space we need. Yes. So what could we do? Actually, let's make a constant and columns, and I'm going to replace 2 here. Columns, and that shouldn't change anything. That'll be the exact same thing because it's still 2. But what happens if now we change this to 3? I wonder if this will work. See, value 1, value 2. So now we actually we can control how many columns we have. And so this would be nice if this was actually a property. So let's create a property. In this case, we are going to create a dependency property. So prop dp is a really good shortcut, just a tab, and it's going to create one for me. And we can just call that columns. Owner class will be my panel, and the default value will be 2. Go and include that namespace, and I really wish this template would use name off. So there's that. So now we can just define it as a dependency property. Columns would be uppercase now. There we go. Now we actually have a cool little panel that can do some stuff. But let's actually try and have some fun with it. And so let me just make this a grid for a minute. And I'm going to say, I'm going to create a little control panel. Stack panel, background, I don't know, white. Border brush, black, thickness 1, margin. I should have a shortcut for creating a control panel. It's pretty much, this is right every single time. I'm gonna put it at the right, vertical alignment top. How about some padding? There we go. And then we're just gonna say slider, value 2. And actually the value we're going to bind to my panel Xbind. Gonna give that a name. Let's call it name my panel columns. Two-way. Gotta remember we have to put the mode in Xbind. It's always one time by default. I'm gonna set a minimum. Oops. Actually, that's not gonna work because this is going to be the slider returns double. So actually, let's just be lazy. We could do a converter on there, but I'm just gonna be really lazy right now. Minimum. Brian, sorry to disappoint you that you're giving you WP app. This will work for WPF. There is really no difference. So let's do 10 columns maximum. And so when this changes, go to definition, we'll say my panel column, got a new value, and we'll cast that to an integer. So here's one of the WinUI problems. So we have to compile first before it finds out that this thing exists. That should hopefully be fixed in a future update. Oh, SunCon, that does not work. Let's try. Oh, sorry, DJ Camporis. I'll try and increase my font a little bit. Is that better? Oh, no, overrained. Oh, okay. So we're getting a build error here, and this is actually one of the known issues. So I use it auto-generate to this thing, and there is a bug currently in WinUI that is documented, so we don't have to bother at actually reporting it, but it creates the wrong shortcut. There we go. We can actually just take this off. This thing where it just grays this stuff out is probably one of my favorite features. Like, you don't really need that, just get rid of it. It's a nice little hint to clean up your code. Now let's see what's going to happen. So I now have two. Oh, I didn't do that very good. Let me hold on. I need to put a width on that thing. Let's try. So when we change the number of columns, well, stuff should change their layout. And it does not work. And there's a reason for that. Actually, let me just run again and I'll show you what's happening in my panel. So I have a dependency property here with a setter. So I'm just going to set a breakpoint, see that it hits this thing when I call the setter. And so I'm going to slide this, and it does set a value, which, by the way, with Xbind it should hit this, but with normal binding, I believe it just calls set values. You cannot ever count on it actually hitting your setter. So we can't really put code in here. We should count on that this thing sets the property, but so it is kind of coming through, but something is not working. And the reason for that is we haven't actually reacted and said, hey, everything's changed. We should lay out again. So the layout isn't running. So we can add a property change callback here. So on columns property changed. And so what we really want to do here is I'm going to cast this to my panel dot invalidate measure. Oh, I did that in reverse. There we go. So I can do invalidate measure. I can do invalidate arrange. And if I invalidate arrange, it's just going to run the arrange. And that's a good thing too, because measure is actually expensive. And you know that your size of your panel is not going to change. There's not really any point in invalidate measure. But because our columns change, our panel could actually become wider. So we do want to invalidate our measure. And so if I hit a breakpoint here, so you would never want to do this up. You're never going to say here like this dot invalidate measure, because if someone were to do something like, I'm just going to write it right here, set value columns property 2, something like that, it would actually never hit the setter. It goes straight to this property change handler. So in your dependency properties, never ever put anything besides the set value code. because it might work when you do it programmatically or with Xbind, but it doesn't always do it. Oh, I'm going to remove this again. And so now let's hopefully see if this works. Oh, it does. Something went wrong with the height for sure. So it looks like we're not getting the right height out. So it's really good to have these background colors and kind of see how it works. And I think I know why, because I don't think we're adding the height in the case where there's an odd number of controls. So let's try that. Actually, let's set the minimum to 1. So, boom, boom, boom. I can basically do that again down here just to be lazy. If columns equals 1, we'll just add it again. This is, oh, that doesn't work. I'm just going to be lazy. Last the default. Site size, height. There should be a better way of doing this. So that'll be 1. Actually, it would not be 0. Can have a fallback for null. There we go. Let's see if that doesn't fix it. This is a bit of a hack, but you get the idea. So this is why it's important to get the right size returns, or your backgrounds and stuff like that might not work. So now let's see. Now we get the right height when there's 3. And even can do 1 here. So that works. Cool little custom control here. Of course, there's probably some margins and stuff on your text. And we could actually do that in the panel. We could say there's a default cell margin. Actually, let's try that. Let's basically just duplicate what we just did. We do property p double cell padding might be a good name. Let's see. That'll be my panel. And so here, it's very important to write the right type. Since we're using a double, the compiler is going to validate this to 0 because, or to integer, because the default type here is object. So it doesn't really know any better. And you actually get a runtime error if you do this. So we have to make sure we say this is of type double, the default value. And so how do we do cell padding? We want to actually add plus cell padding. Probably should only do it if it's not the last row, but I guess we are doing that. And then let's see, x plus cell padding. Well, actually, we only want to do that else. If it's not x plus equal, we'll add the cell padding for the next row or the next column item. And we should do this up here too. Oh, not, yeah. And then we'll do same thing in a range. Add that here. We'll add the padding to the height. Is that about right? I feel like I'm missing something. There we go. Wait, no, that's fine. And so now we have a cell padding, and we got to remember if we change it, it's going to change layout. So on cell padding, property changed. We're going to do something similar. We're just basically covering. I could really use the same method, but I like to have them in sync. Name off. In case I decide to change the name, it's nice to not have string literals in there. It's really good for refactoring. And then let's add a second slider. I should probably have a header here. Columns. Probably if it's still, yeah, you can't do that in WPF. It doesn't have a header property. So padding slider, value changed. Let's try with 0. Let's go all the way to 50. Actually, this one we don't actually have a value change. We can literally, this one we can bind because it's double to double. So we'll say xbind my panel dot, what do we call it, cell padding. Mode equals two-way. Boom. Let's try that. Oh. Ah, it's not the value change event, it's the value event. Or not event, property. Oh, yeah. I love the compiler telling me what I'm doing wrong. I wish life was that easy. Just compile your life for your day and I'll tell you what's wrong. Okay, oh, look at that. Oh, it's not perfect, but I feel like we need a little bit of padding around everything too. But it's pretty good. I think I know how to fix the first bit. I probably shouldn't have actually only did it in some cases. I should probably always add the padding. So I'm gonna do this. And I think we need to start X with cell padding. And we're gonna start Y with cell padding. So we'll do this up here too with, let's probably put X and Y next to each other. That looks nice. And what else did I need to do? We're just gonna do this always. And I guess we can just initialize that to 0. And always do this like that. Let's see if that doesn't look well. Is that gonna work? Because we gotta make sure that the width is calculated with the padding. So we should probably do this first. Now that I think of it, plus L padding, and so this would still have to be that. Go like this. Let's see if that doesn't do it. I think that might do it. So you can kind of get how you can start doing all these really advanced layouts. You could lay things out in a circle or however you want to do it. Let's see. Oh, that is just pure beauty. I am loving this. Oh, a little bit of a bug right there when it's 5, oddly enough. But how many times have you written this with a bunch of grid controls or stack panels inside stack panels? This is just pure beauty. And right now, I believe if I make my, let's say, make my value to text a lot longer, long descriptive text. I'm trying to see what's happening here. I don't think they actually will be very well aligned. See how value 1 and colon is not really aligned very well. So, but we could change that behavior. We could make it a property where you can boolean and say, hey, all columns should be the same width, or each column should be the same width. And so we could basically just do some math and calculate each width and height. Or we can just say, hey, I'm just going to take however much I have. So let's say we say define column width is final size dot width divided by 0, and the final size is never going to have infinity value in it. So you have to be careful with this, of course, on the scroll viewer when you are in measure, but in the range it doesn't really matter. And so here actually we start diverging from measure, where measure says, well, this I'm just going to tell you basically the minimum I need to fit inside your view. But here I can actually say, but given how much size you're going to give me, I'm going to take up all of it in the width, and I'm going to distribute them evenly. And so what final size you get is really up to how you set the alignment of the inside your parent view. So if you set it top left, the final size is basically going to be what the size you're returning here. But if you say stretch, your final size will be the width of your parent, or however my parent says is going to give you. So now we'll really just, instead of adding desired size, I'm going to add this. Oh, there's a little, we gotta actually make room for padding now. So we're gonna say minus cell padding times columns, because math. So a column would be that width minus, and it would be +1 because we have extra padding on either side. I think that's about right. Oh, that shouldn't be 2. I don't know what I'm thinking here. It should be final side width divided by that. So that's how much we're going to assign to each column. So we are going to say, let's see. The width, we actually don't care about the width anymore. We are going to take all of the width. So let's get rid of the width property. And we're just going to say file size of width. And let's see, what else do we need to do? We're adding that. That sounds about right. So now we're just adding the width. So we don't really care about how wide the child is. We're just saying, no, we're going to jump however many columns over we have to get the calculated X value. And I think that might be it. We could do something similar for height. We can also make the height to be evenly distributed. See, now it actually stretches all the way across as we're changing. It's interestingly enough here, 1, 2, 3, 4. You can kind of see what happens. See how we started getting clipping here. I think my calculation is a little bit wrong. Reduce the padding. Something is not quite right. So I think my column calculation is wrong. I know what I did wrong. We got our final size divided by columns minus cell padding. I think it's something like that. Actually, hold on. No. That's not right. The height we have is the width times cell padding times columns. Oh, minus. Was that what I had before? +1. And then divided by columns. I think my column width is not calculated right. Let's just try again. Oh, I'm missing a parentheses. That looks more evenly distributed. There we go. So now we get a little bit better here. So we are seeing here that the text is actually clipping. And what is happening here is with the long-term text is we are actually arranging for more than we have space for. And we shouldn't be doing that. So because I'm here saying child arrange, oh, just use whatever you have available. It's actually not true. We can't use that much. So we might say math.min, whatever is the smallest value, desired size width or column width. Oh, restart that. So let's try again. Do 4 columns, and now I believe, a little luck, kind of see, it's hard to see here, but the text is actually getting clipped. So we're not getting that overlap. So we can actually just arrange it for a bigger size, but then you get these weird overlapping issues where here I can actually clipping it, because in this case the text will say, hey, I need this much space if you have it. And if I then tell, well, you don't have that much space, the text block has decided to just do text clipping. So if it only gets less, it's not going to like shrink or anything. It's just going to clip itself. But if I tell it you have a lot more space, it's going to render in all that space. So it's sort of good to get it ready and get it all working right. And these sliders are really good for testing. You can see with padding here, it starts really clipping because now there's a lot less space left. This is actually useful control. And we could also be even smarter and say, well, we're going to calculate the max width for each column. So this might be multiple steps. First, we run through all the columns. We find which column is, or which child in each column is the widest one. And then we can get all these text to align right here. I'll let you play with that and try and figure that one out. It shouldn't be too hard, but you might just have an array of column width and you just first iterate and figure out what the column should be. And then you just keep going. Let's actually just play a little bit with my stretch here. Let's say we say sender instead of stretch. And you'll see all interesting things going to happen now. I have a feeling my width calculation isn't correct, but you see now it changed the size. So it's saying, hey, I know you only have this much space, but this is how much you're going to get. And so because I'm returning here basically the max size of this text, that's how much you're going to get because it's sender flowed. So final size that I'm getting on a range actually is affected by the layout you're setting up for the alignment. So the grid above you decides that. It makes these decisions. Again, I think there was no, that looks about right. Oh, there are some padding issues at the bottom here. I probably forgot to add padding at the bottom when, let's see if we can fix that when, let's see, column not 0. Looks about right. There's something missing here. It probably should almost always do it. Oh, I'm forgetting to add padding here. That's what's wrong. Let's just put the parentheses so we know which one it's doing. Let's see if that didn't fix it. Again, I probably wouldn't have caught all these issues without these sliders. So that can be really useful for testing your custom panels. So here we go. I think it was just 3 we're seeing an issue. Now we get the right padding at the bottom. So that was just a little bug there. Very cool. This is probably a good setting. Column 2 makes sense. So now we don't have to write all those pesky grid definition, column definition, because you kind of do this all the time. And you could always actually calculate your column height. You could imagine another panel that says you're not going to set the column count. You're going to set a desired minimum width. And then so as you're resizing your parent, you could basically calculate, well, given, let's say you have 300 pixel minimum width on your columns and you get 700 pixels available, and you say, well, I can fit 2 columns. And then so you make each column like 350 to fill up that space, or just 600 if you don't need more. But then as the view changes, you're going to actually be asked, do you need more space? So if you actually, I think if you set a breakpoint here, see the moment I resize the view, it jumps to, for now I have a new available size. So I actually have to run the measure step again to ask you, hey, how much space do you need now? And so you could do all this dynamically. I believe actually in the UWP community toolkit, there are some controls that does exactly this, where as you're expanding, it fits more and more columns in there. And so it could be really cool for these kind of automatic layouts. And you'll see these measure override and range override, they're doing all that work. So I personally love working with panels. It's sort of like a, it was fun to write them, but then it also makes your XAML really clean, because I mean this is pretty cool. This is all I had to write to lay this stuff out. So let's just for fun try and add border background yellow, and let's stretch it. This is also a good thing to try out. I don't actually specify a size. How much does this actually give me? And since we're at it, let's do some more stuff. Let's add a button here, click, add content. This is also a good way to test your buttons. stuff. And so we're gonna have some, let's add a new control. So my panel dot children dot add new, let's just add a text block, do the text property, control number, let's see, my panel dot children dot count. So we'll just add a text block every time we click that button, so we can kind of test a little more dynamic layouts. Oh, we had this problem again. Let's just get rid of the namespace. Okay, so here we can add new controls. Oh, I did not skip one. That's interesting. Where did 0, 1, 2, 3? Something not right. When we have 4 columns. Oh, it's the border I added, which oddly enough didn't render. Let's see what happened in that one. So I'm just going to, just to make debugging simpler, I'm just gonna hide these because then I know there's only one child. Let's see what is happening right here and then arrange. So first we have the full size. The child, the size is 0 right now. We measure it. It is still 0. It doesn't need any size. It's quite interesting. So now we give it desired side width, column width. But maybe what we could do is we could actually say, no, you need to have, this is going to be 0. So no wonder. No wonder. Because we didn't say it needed a size. Let's say, let's give it a min height of 40. I could have been smart here and say, hey, your height that you get is whatever the other rows, the items in the other rows were. Again, I could run a layout step to figure out first what is the maximum height of all the items in that row. And then I would have passed that into my arrange as my size. So let's try now. See, now I have a desired size of 48 because I specified 40, oddly enough. Where is my border? That's really interesting. Let's try again. Let's just resize. Let's see what we get. We have 48 width, 103. So the math min of these two would be 48. X 20, 20, desired height. What am I missing? It's because I don't have anything in it. Hello. So let's try now. Desired width wants to be 19 high. Oh, I did the wrong one. I forgot to set this one to whatever I want. Because min height is different than actual height, right? Let's try again. What did it say here? What did I do? Min height 40. So wouldn't you think the desired size? Oh, I know what I'm doing wrong. I was looking at text block. Forgot I was coming these out. Let's just understand what's going on here and see if we can't fix this. So we're saying desired side width, that makes sense. Desired side height is 40. And yeah. Render. Oh, there it is. I'm not sure what I did wrong. Oh, it's working now. I'll take it. So let's bring this back. Test our little core control out. Oh, I know. I never actually gave it a min width. But the moment I put the text block inside it, it now has a min width. So here we go. We can add more controls. Oh, something odd happened. It's interesting how control goes under. And I believe I have a min height of 40. But I made a mistake. Every time I go down, I say the desired. I never actually calculate the max height of all the items, because that's the one I want to go down on. So let's say double row height 0. So we'll say here row height equals math of max row height and child of desired size dot height. So really what we want to add here is that. We should do this up here so we get the right height calculation. Copy that over here. That should be about right. There we go. Add some more controls. Oh, now look at that. Everything is working beautifully. This is a cool control. Anyone on the chat have any questions or ideas how we can change it? I am all ears. But I hope this gives kind of a good overview over just what you can do with custom panels. It can get really powerful once you get in and do more. Like a great example is the relative layout. I actually wrote an implementation for for WPF because I thought it was such a cool control. So I had this control library called Universal WPF, and let's take a look at this relative panel implementation, and you'll see a lot of code here. So measure override, as we just talked about, but this calculation is actually an iterative process. So it's quite a lot of code to try and calculate, and it's multiple passes to figure out where all the elements go during a range. Quite interesting project to work on. Probably not the best way to do things. I know there's a couple of bugs, but it was a fun project that really exercised what you can do with these arranged layouts. And most of the code here is actually in the arrange, so you don't have to measure everything. We see measure, I basically just do a quick measure of all, and then I just kind of add all this stuff up. So a fun little control to work on. And that's really all I had for today. But this was a cool control. That was fun. Other than that, that's all I had for today. I think next time we'll talk a little more about custom controls, and as opposed to panels, custom controls where we get templating, they're much more efficient than user controls. They're more reusable, they're restylable, especially if you put them in a in a list that's virtualized. You get much better performance than using user controls. So we'll take a look at that next time, hopefully next week. But other than that, thank you for watching, and I'll see you next time. Bye.